How are you students? Welcome back with a new lesson of physics. Speak about the electromagnetic spectrum by Mr. Ibrahim Serria. By the end of this lesson, we must know describe the main features of the electromagnetic spectrum in order of wavelengths and frequency. Second, state that the speed of electromagnetic waves in a vacuum is 3.0 multiplied 10 power 8 meter per second and is approximately the same in air. Third, state applications of each region in electromagnetic spectrum. Fourth, understand the safety issues regarding microwaves and X-ray. At first, what is it? The electromagnetic spectrum is the complete spectrum or continuum of light including the radio waves, infrared, visible ray, ultraviolet light, X-rays and gamma ray. An electromagnetic wave consists of electric and magnetic field which vibrate, thus making waves. So because of this, that electromagnetic waves consist of electric and magnetic field, it means it can spread in space. This diagram shows the order of electromagnetic wave according to its wavelength. The largest wavelengths start with radio wave, after that mobile wave, microwave, radar wave, infrared wave, after that visible waves, ultraviolet, X-ray and gamma ray. Gamma ray is the shortest wavelength and radio wave is the largest wavelength. Penetration of electromagnetic wave increase with decreasing the wavelength. It means gamma ray is high penetration but radio wave is low penetration. This is the electromagnetic spectrum. Nature of electromagnetic wave. They are transverse wave. We said before, transverse wave, it means the propagation will be perpendicular to the direction of spread with the medium. They can travel through empty spaces, yes, because it consists of propagating electric and magnetic field, not particles. They travel as vibrations in electrical and magnetic fields. Have some magnetic and some electrical properties to them. It's vibration of electrical and magnetic fields, so it will have some of properties of electrical and magnetic also. The speed of electromagnetic waves equal 300 million meter per second or 3 multiplied 10 power 8 meter per second. Takes light 8 minutes to move from sun to earth, 150 million miles at this speed. Waves or particles. Electromagnetic radiation has properties of waves but also can be thought of as stream of particles. It means light is electromagnetic waves, so light can have the properties of particles beside electromagnetic or wave properties. Example, light as wave. Light behaves as a transverse wave which can filter using polarized lenses. Polarized lenses, this is the lens has ability to pass some wavelengths and prevent some other to pass through it. Light as particles, photons. If I ask you which light consists of, it means it consists of photons or transverse wave. Photons is a small particle, you will study it after that. Photons is a particle, rest mass of photons equals 0, but it has a mass when it moving. When directed at a substance's, light can knock electrons off of a substances. This is phenomena called photoelectric effect and we use it in many applications. Wavelengths, frequency and energy. What is the relation between wavelengths, frequency and energy? Since all light travels at the same speed, wavelength and frequency have an indirect relationship. It means Light with a short wavelength will have a high frequency, and light with long wavelengths have a low frequency. This because the speed of light is a constant and equal what? Yes, 3 multiplied 10 power 8 meters per second. So if the wavelengths decrease, frequency will increase, and if wavelengths increase, the frequency is decrease. Must have the multiplication of frequency and wavelengths must be a constant. Light with a short wavelength has high energy, and long wavelengths has low energy. Light with short wavelengths has high energy, and we said before, gamma ray is the shortest wavelength and has power for penetration through material. But the longest wavelength, like radio wave, is low power and it has a low penetration or power penetration through the material. Radio waves have the longest wavelengths and lowest frequencies of all the electromagnetic waves. A radio picks up radio waves through an antenna and converts it to sound waves. Each radio station in an area broadcasts or a different frequency on radio dial tells frequency. Uses short wave radio waves with a magnet to create an image. Microwaves. Microwave longer than radio but shorter than light and infrared. Wavelengths 1 multiplied 10 power minus 4 meters to 1 multiplied 10 power minus 1 meter. First used in order, now used in communications, medicine, and consumers use microwave oven. It has ability to raise up the degree or the temperatures of materials. Infrared waves, invisible electromagnetic waves that are detected as heat. All waves which we talk about, radio wave and microwave, all we can't see it. We can't see it. Also infrared, I can't see it. Invisible, it means I can't see it. Electromagnetic waves that are detected as heat can be detected with special devices such as night goggles used in heat lamps, heater energy than microwaves but lower than visible light. So infrared light has energy for heating than microwaves, but it's lower than light. Why? Because it is low energy or less power than visible light, because visible light is shorter wavelengths. Visible light, the portion of electromagnetic spectrum that human eyes can detect, ROYGPIV. This is rainbow color: red, orange, yellow, green, blue, indigo, and violet. Red is the lowest frequency and violet is the highest frequency. Ultraviolet, higher energy than light wave because it, yes, has shorter wavelengths than light or visible light. Can cause skin cancer and blindness in humans. Used in training beads and sterilizing equipment. Wavelength nanometer. This is visible light between 700 nanometer to 400 nanometer. The shortest one. After that we have ultraviolet. Before that we have infrared. We start with radio wave, infrared, visible light, ultraviolet, X-ray, and gamma ray. X-ray, high energy waves, first discovered by Rontgen, used in medicine, industry, and astronomy. Can cause a cancer. We use it in a medical field because it penetrates our body, can penetrate our body easily, and we can see things inside our body like skeleton and see the infection inside our body. Gamma ray is the shortest wavelength and high frequency. than X-rays, has highest power energy, carry the greatest amount of energy, and penetrate the most. Used in radiation treatments to kill cancer cells. Also, we use it in a medical field for treating cancer, but it's dangerous for our body also because it kills all cell, not only the cancer, but we can concentrate it at a fixed point or infected part of our body by cancer cell. Can be very harmful if not used correctly. Some frequencies and wavelengths of common EMF waves. Electromagnetic. EM is abbreviation about electromagnetic. Type, power lines. Frequency, power lines in our house. The frequency is 60 Hz, between 50 and 60 Hz. Its wavelength equal 5 multiplied 10 meter, about 3,100 miles. Television, 1 megahertz. M, it means million. M, it means million. So this is 1 million hertz. Its wavelength is 300 meter. Thank you and goodbye with a new lesson in next week, inshallah. Thank you.